Good evening, everyone. So we're going to continue from where we left off last time with networking fundamentals. We're going to do some refresher, right? Some revision of what we learned, um, right? And then we're going to log into our accounts today and do some hands-on work, right? So we talked of networking last time. Let's see. So what's a client? Anybody want to try? What's a client?
I can do it.
Go ahead. What's a client?
A client is like a computer, phone, or app that wants to access something.
Yeah, that's an example of a client, not the client itself. That's a client. That's an example of a client. What's a client?
A client is someone who give a request or request something from a server.
Close, very close. Not
Is it a device? Is a like a software that requests services from a server?
close. That's what I'm looking for. It's an English word. A client is a something. Then I end the answer.
User, a user.
Mm, could be user or device or tool. I'm looking for a word. Looking for a keyword.
Request?
Request is an answer, but that's not a complete answer. What's a client? In IT terminology, what's a client in IT?
Okay, it's an application used to connect to a server.
It's a client is an application or a tool that sends requests to connect to the server. That's it. A client is an application or a tool. What is WhatsApp on your phone?
Hmm.
A
That's a
It's a
client.
client.
client. It's a client.
Is that an app? Is that an app?
Yes.
Yes.
Is it a tool?
Yes.
What tool is it? What do you use our WhatsApp for?
Messaging.
Communication,
There you go. What else? If you want to buy a flight online, what tool would you use?
Flight purchasing application.
Price line. Mm, anything.
Expedia,
Yeah.
Which one is the client? Which one is the server? Priceline mobile app or
Domain name.
.com?
Mobile app will be the
the, the,
client.
appli- the application is
No,
a
no, no, no,
client.
no, no. You guys are getting the answer wrong. If I interview you guys, you're getting the answer wrong. Listen to the question, and please, just one person at a time. Which one is the client? Which one is the server? The Priceline app on your phone or Amazon.com?
The Priceline app
Amazon
is a client. The Amazon.com is
is
a
a server.
server.
So, what is the client?
A client, I think, is a software device that's being used to send requests.
Guy, the answer is right in front of you. Are you guys seeing my screen?
It's an application or a tool that sends a request to connect to a server.
The reason I'm doing this exercise intentionally. Guys, when you finish this class in 4 months, you may not be ready for interviews. You may have to read the answer on your screen. This is an interview notebook. Every answer that you're going to ask you in an interview, every question that they're going to be asked in an interview, I have it in this one notebook here. I have it. I have the answers. I have the questions. I have the answers. Everything is here. What I just did now is Ayamba wasn't paying attention to my screen. Sometimes the answer is in front of you. You have to just look and read the screen and get the job. That's what we do. A client, you use it every day. The WhatsApp app on your phone is the client. WhatsApp.com is the server. So today, we are going to log into AWS platform to create what? A server. What clients are we going to use to connect to AWS? What is this called?
Firefox.
Thank you. That is the client. So maybe I should draw it out. Today, I'm in Dallas. I'm connected using this client. This is me. I'm connected using Firefox. What is my IP address? Let me grab that. Come on, just checking it. That's my IP address. It's the same thing like last time. It hasn't changed because I'm in the house. Well, I haven't left the house since Monday, actually. That's my IP address. What is it? 172 dot something? It's 72.192.2.2.10. So this is interesting. 72.190.22.10. I love numbers. This is the client. We are about to connect to a server. We don't know where it is. It's North Virginia. We're going to choose a region, North Virginia. North Virginia. That's what the server is. Hey, I'm not going to teach you guys regions and availability zones. This is not a cloud class. This is not an AWS cloud engineer class. No. You just know that your server is North Virginia. And you're going to select it when you're selecting what to create your server. And this is the server. It's in the cloud. You cannot see, you cannot touch it. It's controlled by AWS, right? This is the platform, it's going to be AWS. Different day we will do Azure or Google, it doesn't matter. It doesn't matter where it is. And this client will be connecting to a server. This is a server here. And the server is going to be a Linux operating system server. That's the operating system. So this client will connect from here to this server. Like that. Question, how would this client connect to the server? Over what? What's in the middle? Come on.
Transport layer.
Come on,
No.
guys. What's in the middle? How does a client connect to the server? This server, okay, I'm in Dallas on Firefox on my laptop. I want to connect to a server in North Virginia.
It has to hop through different data zip codes to get there.
Yes, but in what? What is it called?
Zip codes.
What is this called? How do I connect to North Virginia? Over what? Using what?
The domain name.
Come on, guys. Come on.
Credentials?
The internet. Internet now. It's the internet now. How am I going to connect from here to Virginia? It's the internet. Right? It's the internet, guys. Come on, guys. Come on, man. Come on, wake up. It's the internet. I'm going to go over the internet to connect to that server. Where's the
You're
diagram?
not logging to the internet. That's true.
I'm on the internet right now, right? How are we attending class?
Via internet.
Internet.
Yes. What are you using to connect to this Zoom call?
Client.
Credentials.
Hold on. This
Zoom.
is Zoom.
Mhm.
This is Isabel. Isabel, what browser are you using right now?
Home.
Okay, you're using Chrome. Do you have the Zoom app installed on your laptop like this? Or you're
No,
just connected with the browser?
I connected with the browser.
Okay, that means that your client is Chrome. And you're connected to this Zoom meeting. And this Zoom Chrome client connected to what? The Zoom server. Because I have an account with Zoom Workplace. I have an account with Zoom right here. This is my account with Zoom. You're able to connect to the Zoom server. And when you connect to the Zoom server, you put the meeting passcode, you connect it to this meeting. We don't know where the Zoom server is. We don't know where it is. It could be anywhere. We don't know. It's unknown. I don't know where it is. So this is what we're doing. Every day of our lives as SRE engineers, as cloud support engineers, we are using a client to connect to a server. Guys, if there's nothing you learn in this class, this should be the only thing, this should be one of the things that is permanent in your brains. Burn it right now in your brains. When they say burn a disk, stamp it in your brain. Every day of your life, you are connecting from a client to a server. You do it, but you don't know it. You want to buy a flight, you go on pricing.com. That is what is happening. And you are doing so over the internet. Everything you are doing is over the internet. You connect from TikTok app on your phone. You log in to your TikTok. You are connected to the TikTok server. TikTok app over the internet. So normal users, customers do this every day. As SRE engineers, we are going to be connecting from the back end. You as a normal human being using these applications to buy insurance, to buy flights, to buy videos on TikTok, this is how you're going to be connecting. Zoom, you're going to connect. TikTok, you're going to connect. But when you want to repair, if you want to repair this server, let's say a Zoom, you work for Zoom.com. It's a big company, by the way. They have a huge office in China. If you work for Zoom.com and they say, oh, this is unable to connect to Zoom meetings, so there's an issue with the server. You, an SRE engineer, are you going to connect to Zoom.com via the Zoom app, or you're going to log in from the back end? You log in from the back end because you are there. Isabel, who is there? SRE engineer. Is the SRE engineer. In order for this application to appear like this Zoom Workplace, they have written code. Developers have built code in the back for this to show up like this. So if I'm unable to log in, I'm paying for this, right? I'm paying for this. This is it's a subscription. If I'm not able to log into my Zoom application like this, because I'm paying for it, and I complain, Isabel will go log in to the back of the server and log into here and troubleshoot it and see what the issue is. And then when she fixes it, these users now will be able to connect going forward. So in the back end here, when this user is connecting to repair this application, guess what they go over? The internet. They go over the internet as well. And guess what? This is also a client. And then this is the server. So whether you're a normal user buying online or you're an SRE engineer, you will always connect to a server using a client. I want this to stay permanent. The whole thing that makes us SRE engineers is being able to connect to this server and fix issues. We are cloud support engineers. The fancy name is just site reliability engineer, but then really we are cloud support engineer. We're support engineers. Making 110, making 120, 130, 140, you're a support engineer. AWS pays their support engineers 150K. That's it. It's a very basic, simple job. It's basic. It is. It's not anything hard. You're going to just connect to here, check the system, run some commands, fix the issue, report back, send an email, done. That's it. You don't have to draw no diagrams. You don't have to write any code. It's a very, very basic job. So I want you to understand that this you're seeing is very basic. Every day of your lives, you connect from a client to a server over the internet. If you don't have data or internet, you cannot connect. Isabel can send a message from here, from TikTok, and you don't receive it. If she sends it and it goes, it shows one tick on WhatsApp. It's gone from her phone. If you don't receive it here, you don't have internet. Internet is in the middle. So all of us are supposed to have internet. If you don't receive my text message, you don't have internet. Same thing here. If the user cannot connect to the Zoom app, what can be the issue? Here, what do we have here? We have layer 1, layer 2, layer 3. Where's layer 4?
Between the server and the client.
There you go. Welcome, Chris. And where's layer 5? On the side. Layer
On the server side.
5, 6, 7. So when Isabel connects to the server and starts troubleshooting issues, she has checked layer 5, 6, 7. Oh, we are good here. And then the developer that built the mobile app, this is very important. The developers, they call them mobile app developers, iOS, Android, iPhone, Google phone, they build the mobile apps. All the mobile apps on your phone, they have a special team called the mobile app team. They go and check the mobile app. What do they check? Layer 1, 2, 3. Oh, we're good over here. At that point, they'll report back to you that, hey, SRE, Isabel, we're good. So Isabel will say, okay, it means the issue is at layer 4. And what is layer 4?
The transport layer.
Transportation layer. That's when we'll go now and start running commands. Ping zoom.com to see if it's going through. Oh, look at that. It's not going through. Request is timing out. That means the zoom.com server has an issue. We just transmitted 9 packets. So my system is good. I was able to send 9 packets, but the server received 0 packets. So 100 packet loss just occurred. Okay, let me see if I can ping another server and see if it's really my issue again, if it's really on my end. Ping www.facebook.com. It's going. So what does that mean? The issue is at zoom.com. Questions before we go forward? Is it clear now what we're doing here? Is it clear about this? Networking is the only thing that you need to know as an SRE. We might not even go into security because you need to know how to connect. You need to know how to connect to systems. Every application in the world, Geico.com, Amazon.com, everything.com, they run on a server. You need to know how to connect to the servers to troubleshoot them. You need to know what layer the issue is. Most of the time, the issue will be in layer 7 or layer 4. Let me say it again. In an interview, that will ask you this question. At what layer are most application issues? It's mostly at layer 7 or layer 4. When the packet is transmitted over to the server, it goes to session. Session will start. The session will always start and it will log the session and it will end. Presentation is always presented. Data will be presented to you unless you have like they call it corruption, where the data gets corrupted. The application is what you see. If it's not, if you refresh it, refresh, it's not coming up. That is the application. You see error 505, 504 error, 505 error, 503 error. Database request failed. That's application. That's all application layer. Layer 7 is going to be where you're going to troubleshoot a lot. And layer 4. Layer 4 is, since it's transportation layer, the first command you run is a ping. You try to ping the server from the client. So you go on the client, you connect to the client, and try to ping the server to see if it can, requests can go from here to here. If it doesn't go through, then you start troubleshooting. We're going to learn many other commands. We're going to do a dig. When you run a dig command does what? The dig is going to look at the hops. Okay, let me get to this hop first to see where the issue is. I'm in Dallas. I want to connect to North Virginia. So from Dallas, I go to Oklahoma, Kentucky, Philadelphia, North Virginia. So I'm going to run a command to check how many hops is my request going from Dallas to Virginia. How many hops is it? When I see the hops, I can start going in detail now. Okay, let me see the hop between Dallas and Oklahoma. Is it going through? Okay, it goes through. The next hop is Oklahoma to Kentucky. Let me investigate that hop. It's fine. The next hop. Then you say, oh, between Philadelphia and North Virginia, the hop is broken. So that's research option. Oh, see, Philadelphia and Virginia, the hop is broken. That's what the issue is. Then you go research now. If North Virginia has reported connectivity issues, because if Philadelphia cannot connect to North Virginia, maybe North Virginia has connectivity issues. Now we can go try and connect from a different server. We can say, okay, let's connect from Florida. This is called narrowing down the issue. Let's connect from Florida to see if it's New York, is North Virginia is really the issue. We're going from Florida, and we're able to connect to North Virginia. Oh, it's working. Okay, let's see if we can connect to Philadelphia. And we try to connect to Philadelphia, it cannot connect. That's our issue. That's how networking is, that's how this thing works. Okay? Any questions on what we're doing? I'm trying to nail down client-server relationship. It's all what we've been doing from the beginning to now. It's all revolved around, right? The DNS, right? When the client makes a request, connect to a server, DNS resolution occurs here, goes to the load balancer, the load goes down here, it sits on the server, and then it goes down to the application load balancer, goes to the application layer. This is all the clients send the requests to the server, and the server intents sends a request to this load balancer. The load balancer serves this. Let me explain. When a request comes from the client, it hits the load balancer. The load balancer acts as a distributor. Oh, I'm going to take a request and distribute it to among many guys, so that all these servers can take your work and do your work. If there were no load balancers and multiple servers, you'll be waiting for the movie to load on Netflix. Like, you'll be spinning like this before it shows. In the beginning, when Netflix was created, it was spinning like this. But now Netflix is more faster because they have load balancer. They have thousands of servers behind the load balancer that processes your request faster and your movie plays. If you realize now your movies are not slow anymore. It plays fast. Even though you have slow internet, you're able to watch movies on Netflix. The load balancer acts as a distributor. The load balancer acts as a distributor. And your load is spread across multiple servers. But when these servers go down, this is for users. This is for Netflix.com users who are paying monthly. They connect like this on Netflix.com or Geico.com, whatever application it is. Us that need to fix the servers when it goes down or there's issues. We don't connect like this. We connect from the back end, direct to the server. And we use clients like Firefox, Chrome, or things like VS Code, or PyCharm, right? We use other tools to connect or terminal to connect, right? This is how we connect to the servers. Okay, so that's what I wanted to explain. And then now we're going to go create a server and we're going to connect to it. How are we connecting to this server? We're connecting to the server from the back end. We're connecting to the server from the back end. This is what we're about to do today. We're going to connect the server from there, back end. Client, server. When the application is built on this server and is running, then we're going to use the app. We're going to use a Zoom app, Zoom mobile app, but we're going to connect to a server from the back end. That's what we're going to do today. Any questions? Yes? No?
The difference between the DNS process and the Open Systems Interconnect process.
Mm-hmm.
So they work together.
There's no difference, right?
It's the same.
No. The DNS process is this. What happens when you open www.example.com? What happens when you type that in your browser? That is called, this is the DNS resolution process. That's simple as that. The resolving name server which is this is a name server right here. This is a domain name, right? This guy goes to the operating system. To check if the IP address for this domain name exists in the operating system cache. Right? If the IP address is not there, then you need to do a DNS resolution. If no, then it has to do a DNS resolution process. And it starts from here. Where does it go next?
The root server.
Yeah.
And it asks the root server, hey, do you know where example.com is? And if it says no, I don't, where does it go next?
Top levels domain.
What's that?
Top level setting.
Thank you. Top level domain. And it asks top level domain, hey, do you know where example.com is? It says, no, I don't know where example.com is, but I know where
Com.
the com servers are stored. And where does it go next?
Authoritative.
There you go. Because when you bought the domain name, you had to register it and pay for it, right? Domain names are not free. You have to pay for it. Authoritative name server. And then this guy goes now and say, hey, do you know where the authoritative name servers are? So, yes, I know where it is. And it gives him the IP address. Go to 192.168.1.1. And the root name server takes that domain name, goes back to here, and opens it up. 192.168.1. That's it. That's DNS resolution. The OSI model is simply how data moves from your laptop out into the internet. The OSI model is simply how data moves from your laptop, physical layer, what's the next layer?
Data link layer.
What's the next layer?
Network layer.
This is simply how data moves from your laptop out to the internet. That's what the OSI model is. They are different. They're not the same thing. Layer 4 is?
Trans-
And layer 4 is always where? Where's layer 4 always? Between who
In the
and
middle. The
Between
middle.
between the client and the server.
Thank you. Between the client and the server. That's where layer 4 is. Layer 4 is never attached to anybody. He's by himself here. What's layer 5?
Session.
And the session layer, what happened in the session layer?
Session start time, session end time.
Thank you.
That's where you generate the logs, right?
Yes, generate logs. Layer 6, what?
Presentation layer.
And this is what? Data format. The format. Right? Some people will see hieroglyphics, some people will see Israel language, some people will see English language, all those things, right? And layer 7 is what?
Application.
Application.
Yeah, application layer. Where would you see most issues while working?
The
And this seven layer.
Application layer.
The
Application layer.
network.
And layer 4,
4 and 7.
4 and 7, because 4 is network. That's why I am teaching so much networking, guys. Right? A lot of issues is the network issues. When developers write code, they don't make mistakes. When the application is working fine, it's working fine. If users cannot connect, there is a big issue. I just got a big contract with AT&T recently. I just got this today, and they're telling me that they made number one issue that AT&T is facing is connectivity issues. Connectivity issues number one. Connectivity issues. Spectrum internet keeps going down every day. Spectrum is going down. It's going down because of connectivity issues. So that's the DNS process. DNS is opening up a domain name, Kobe. DNS is simply opening up a domain name. The domain name, every domain name has an IP address behind it. You just saw Facebook's own. Where is it? ping.facebook.com. That's the IP. That's it. So when you type facebook.com online in your browser, it has to resolve to this IP address or that IP that you just saw, this one right here. 3131. That's this. Human beings don't remember this name. The IP address of the facebook.com server is this 31.13.19 this. This IP address resembles an IP address from Boston because that's where Facebook has its servers in Boston, Massachusetts. And the IP is like this because of the Boston zip code that they use in Boston. For any company that hosts servers in Dallas, it will have a 7.2 IP address, 7.2 dot something else, right? So the DNS resolution process is just what happens behind the scenes before the website opens. Again, the server is an IP address. The server needs to open up. The website needs to open up using the IP address. And the IP address, we don't remember the IP address as human beings, but remember the domain name. So when we type the domain name on our browser, it goes through this process before the website opens because it needs to take the IP address and open the IP address on our browser. Remember, without an IP address, you cannot exist on the internet. Server, client, cars, Alexa, refrigerators, smartwatches, phones. Without an IP address, you cannot get internet. So everything on the internet has an IP address. Because we cannot remember the IP address, companies use the domain name because it's a friendly name. But really, we are really trying to get to the IP address they would type example.com. But the IP address behind example.com is really this number. Again, this is an example. So this is the domain resolution process is different than the OSI model process. The OSI is how data moves from your laptop to your Wi-Fi in your house, to the internet, across the internet to the application, connects to the server, session starts, it's presented and formatted, and then you see the application. That's OSI model. Is it clear?
Yeah, yeah. I was just wondering if they work together in some way. But
And
no, I
guess what? And guess what? All of this layer 1, 2, 3 is what? What is that?
Client side.
understand.
Client side.
And layer 7, 6, 5 is what?
Server side.
Server. So
So if you have an issue on layer 7, 6, or 5, what would you tell the customer or your boss or your manager? Hey, I discovered what the issue is. It's out there,
Server side.
server side. You're speaking my language now. Why do I say so? I'm teaching you this. You're going to see something. You just Google server side errors. Server side errors, error code. Server side error codes are the errors that happen on the server or the back end that hosts the application. Server side errors happens on the server. Where's the server? On the server, where is it? Right here. On this server or the back end that hosts the server. Where is it? Right here, right here, right here. On the server, this is the server or the back end. This is what they call the back end. This is the application. This is the database. This is the back end of an application. Everything from the application and the database, that's the back end. Here is the front end. Can you guys see my mouse? Let me use a draw. This is important, right? This is we're getting to the meat and potato. This is it. This is it. This is what you do on the job every day. I'm going to repeat it again next class, but this is it. Where is my line? Let me draw. Right here.
the front end.
This is the front end. The web layer is the front end, guys. Hello. The web layer is the front end. Let me use red because the back end is a no-go area. The back end is a no-no. The back end, we don't play with the back end.
So it means users log in and enter the front end, right?
Yes. When you go to geico.com, you are only on the front end. When you buy insurance and you have an account with Geico and you're paying, that's when your request gets to the back end. Hello? You don't pay us any money. Why are you trying to get to the back end? You see what I'm saying? You haven't bought insurance. You're just browsing. When you buy some auto insurance and you pay us some money, then that payment that you made, your credit card number, your address, all the information will be sent to the back end for processing. This is our money maker. This is red. This application servers 1, 2, 3, 4, and database backend. This is the back end. This is what really makes us money. So SREs, us, where do we connect to resolve issues? The back end. That's why they pay us so much money. Because you're working on a server that gives the company money. It's a critical role. If it was, you know how much web developers make? The guys that work on the web, they make 80,000, 75,000 a year. That's nothing. Because they're working with irrelevant requests. You're browsing the geico.com, sitting there browsing, you're not buying. Then you say, oh, I cannot connect. Man, get out of here. When you buy insurance, you have an account and you pay your money and you cannot connect, we are going to be panicking. SREs are panicking. Hey, I need to connect. The customer is waiting. Because you have paid us money. So this is the back end. The back end is right here. The back end. This is the front end. So Let me show you guys something real quick. Let's do this erase. Go back to my mouse. Look at this. Back end developers salary. Look at that. That's it. Entry-level back-end developers, that's how much they make. Okay, look at front end. Look at that. That's it. Okay. Look at SRE. You see what I'm saying? Who is more important? The person who came and installed the bulb and the electricity in your house, or the person who keeps the light on? Who is more important?
The
We are
person
more. The person who keeps the light on is more important. If not, there will be darkness. The guy who installed the light can come and fix it one day and go him away. We are here every day, 24 hours, 7 days a week, keeping the lights on. So they will pay us more money, more than the developer. The developer does the job one time. Our job is every day. Chaque jour. We are checking. We are monitoring. Checking. The day you sleep up and you sleep, server go down. Outage. Company is losing $180,000 per hour. It happened 2015. So as SREs, if you want to make 220,000 as SRE, you may have to do on-call. You may have to be up at 2 a.m. at night working, being on call. You have to work at something called the NOC. NOC is a Network Operations Center. I'll show you. NOC jobs are pain. You wear a sweater. Look at this. Look at this. Look at this image. This is where you're sitting. Look at this. Your chair is here. You're looking at 17 screens at the same time. This is a NOC office. They still have this today. Verizon in Plano, they have it here. They have a NOC. You can sit there and looking at that big screen. It's showing green, orange. It's showing green and yellow. If anything turns red, then it's panic. It's showing green, yellow. What yellow is warning, warning, warning. So you can have 500 green, 40 yellow. If something turns from yellow to red, you leave everything you're doing and you focus on that red. But that's NOC. It's very, very cold in here. Very, very cold. Because these screens get hot. You work there overnight. They pay you more money, but you don't sleep in your house. I've done it before. Okay? But because of cloud, this doesn't really exist anymore. Okay? Okay, we're beating the horse to death. Let's log into a server. Let's create a server now. I'm going to go to my accounts. aws.amazon.com. Let's start Amazon. And I'm going to log in. I'm going to put the link in the chat. We'll do it together, okay? We are going to log into and create a server now. Now we're going to a platform where AWS rents servers, right? We're going to a platform where they rent servers. Any questions so far? Any questions so far, guys? No? All right, let's log in. Let's log in. I'm going to go to my server. I'm going to log in. Sign into console. What is this? So you see your login. You can log in as root. Most of you have to log in as root. So my root user email is Dormo. I have it somewhere here. Dormo Shopping. That's my user email. I'm going to click next. That's my password, and I'm going to click sign in. It's going to ask you for this, keep your account secure. Just skip for now. And boom, I'm logged in. Oh, look at my bill. Oh, goodness gracious. Whenever I log in, please let me know. I want to make sure we're on the same page. When you log in, just tell me, just put in the chat, logged in or yes or something, so I can know you're logged in. If you don't have an account, you'll not be able to follow up with us. You're gonna have to wait next time. Or I'll give you guys notes on how to log in.
I logged in. Mine's looks a little bit different. You know, it says global right here in North Virginia. Okay, I see that. They're billing a cost. No, I think I'm near. Just looks slightly different.
Make sure you're in North Virginia, guys.
North Virginia.
Make sure you're in North Virginia. You see other regions. Make sure you come here and click here. Make sure you're in North Virginia. That's what we want to focus on, right? Again, look at our diagram, right? Our diagram says we're going from Dallas to North Virginia. Wherever you are, Chicago, we're going to North Virginia, okay? We're going to connect in North Virginia in the back.
So what problems have you had since you've
You're watching TV during class? Come on, man. You're better than that. Please be here. I only have you for 2 hours among 24 hours in a day, right? We're going to connect to the back end right here. This is AWS. And this is me. I'm in Dallas. Oh, Isabella's in Dallas too. So Isabella's connecting. And she's the client. This is what we'll focus on. Right here. This is what we are focused on right here. Take a different color. Blue. This is what we're focused on.
Are we supposed to see that diagram right now on ours or no?
I'm showing you that this is what we're focused on. We're trying to connect from clients to this server in North Virginia. We already have our clients, right? We are already as Firefox right now, right? Whatever browser you're using, I'm currently as Firefox right now, right? I'm currently Firefox right now. So this is Firefox. We want to connect to a server in North Virginia. We have opened a platform where they sell servers. Claire, how do you clear our drives? How do you clear this stuff? Erase. Okay. Is everybody logged in? Let me just check one more time. Yeah, Brett, you have to create an account, man. I said this like weeks ago. Like it's over a month ago, actually. All right, since you have to create an account, man. Right.
I already did.
So you should really log into your account, right? I don't want to hold a
I am.
You can't log in. You just say you can't log in.
Yeah, just go ahead because I don't have an account yet for me because I told you we're doing Google Cloud. I'll do this now, just quick. I'll join you.
Well, guys, I sent an email that everyone should create 3 accounts. AWS.
I created the account. I can't log in. That's what I'm telling you. And I can't see what you see.
Well, then you don't have an account. You don't have an account.
Okay.
Yeah. If you cannot log into an account, you don't have an account. It's just that simple. All right. You have to just watch. You catch up later on. All right. So if everyone on this landing page, so what you see here, I'm going to explain what is. We're not learning the first cloud, AWS. We're going to go to Azure. We're going to go to Google Cloud. What you see here is the cloud, right? What you see here is the cloud. This is AWS cloud, Amazon Web Services. Please mute yourself. Please mute yourself. Mute yourself. What you see here is Amazon Web Services, and they have various services for various things. They have service for business applications, compute. Compute means CPU and memory. Compute means CPU and memory. Compute means CPU and memory. I'm repeating it many times because I want you to write it down. Compute means CPU and memory. Storage and compute are 2 separate things when it comes to the cloud. When it comes to on-premise servers, everything is in one server. In the cloud, compute is separate from storage. They couple the 2. So compute is CPU and memory, while storage is storage. So this is compute, and down here, you have storage. 2 separate things. Then when we build a server, we take compute and we take storage, and we'll build it. Now we're about to build a server in the cloud. So this is what we want to do. Virtual servers in the cloud, right here. It's called EC2. EC2 means Elastic Compute Cloud. EC2 means Elastic Compute Cloud. So compute cloud. So that's two C's. So we just say EC2, right? Compute cloud. Elastic Compute Cloud. So EC2. That's the first one I want to do. Click on this star right here. So you become our favorite, so we can always go back to it. We're going to click on, then we'll click on it. Then we're going to click on it to open it up. When you click on EC2, you will see this page right here. Okay. Is everybody here? Everybody see EC2 dashboard? Yes? No? Maybe?
Yes, I'm there.
Yes.
Guys, with this one, I will need people to
Yes.
confirm with me because I don't want to leave anybody behind.
Yes.
Okay. So next thing, this is the EC2 dashboard. This is the dashboard that you're going to be seeing a lot. If you go join a company that uses AWS as an SRE engineer, you'll be seeing this a lot. All the resources means the services AWS offers. They offer resources. So within this service, EC2 is a service within AWS. It's called a service because you pay as you go. It's not a product. You don't have it physically. You pay as you go. So within the EC2 service, you have the following resources: instances, auto-scaling groups, volumes, snapshots, security groups, all these things. Okay? But we're only going to focus on two: instances and volumes. Please mute yourself, guys. This video, please mute yourselves. We're going to focus on instances and volumes, which is instances is compute and volumes is storage. Again, from the very beginning of class, our focus has been what? CPU, memory, and storage. That's it. That's it. So now we want to build our server. From this diagram, we have our client. Client is Firefox. That's my client. Now we want to build a server in North Virginia and connect to it. We're going to build the server. We're going to create a server. And then we're going to connect to it over what? Over the internet. Okay? So, one EC2. Next thing we want to do, if you look at this EC2, you see the service health. See, this is a health dashboard. Amazon is saying this is a region, US East North Virginia. This service is operating normally. You want to see this. If you don't see this, then it means something is wrong. These are the various zones in North Virginia. They have the various zones, A, B, C, D, E, F. They have 6 zones. These zones means a separate building. So North Virginia is a state, right? In North Virginia, you have Hendon, you have Arlington, you have different cities in North Virginia. So AWS or Amazon has built different data centers, different huge buildings where they have computers that they want to rent to people online. So in US 1A, it's a separate building that it's about 500 kilometers or less to this next building. So for example, this could be in Arlington, Virginia. This is in Hendon, Virginia. This is in Westchester, Virginia. This is in Stafford, Virginia. This is in Tyson's Corner, Virginia. And this is in a different city in Virginia. But they're all within North Virginia geographical limits. But they are distance away from each other. But they are all connected to each other using phone lines, using physical cables. This is the reason why companies will deploy their applications in this region, in the servers that live in this region, because it is highly available. They have 6 data centers. So when you create a server, your server can be fault tolerant, meaning that if one region goes down or one zone goes down, your server can run in the next 6. So the load balancer that we're talking about, this guy, load balancer, if you have 6 servers in USS1 A, B, C, D, E, F, the load balancer can send your traffic to any of these zones behind the scenes. Any one of them. Okay? So note that that's why the cloud is highly available, because the cloud has many, many regions. If you can see here, in the United States, we have North Virginia, we have Ohio, we have Northern California, and we have Oregon. We have 4 regions within the United States. So if your application is running in North Virginia, and North Virginia has a hurricane that hit them and it goes down, your application, the load balancer, who is the one that spreads traffic across servers, would take all the requests that were on that server and move it over to Oregon in a completely different geographical region, and business continues. That is the power of the cloud. Any questions so far before we go and create a server?
I have a question.
Yes.
I'd like to know if we need to memorize all these names like you did.
No,
Okay.
you don't need to memorize your name. Because you work in the cloud. Because you work in the cloud. You don't work in AWS cloud, you work in the cloud. Any cloud. In Azure, in Microsoft Azure, they have regions as well. The names are different. I want you to remember only North Virginia. Let me say it again. I want you to remember only North Virginia. Don't remember the code, US East, no. Remember just North Virginia. Because in Azure, I only know one region in Azure, Oklahoma. But the code name is US Central, because Oklahoma is in the center of the United States. In Google Cloud, I only know San Francisco. That's it. Because these cities, these state names are friendly names we can remember. I cannot remember all these codes, AP South 1, AP Northeast 3. I don't know. It's too much. Guys, in IT, we don't cram. We don't cram. We know where to go find the information. We bookmark the link. These are called bookmarks. Azure bookmarks, I have a bookmark. I bookmark it. Portal bookmarks, I bookmark it. We don't cram information. We don't cram IPs, names, none of that stuff. We don't cram commands. We know where to go find the commands right here. Cheat sheets. We know where to go find the commands. We don't cram the commands. So in your interview, make sure you emphasize that you don't cram. You know where to go find information. That's it. Okay? Your brain is not a memory to cram stuff. So don't cram names, please. Only remember the main name that you use every day. Because I'll ask you in the interview, oh, where did you create your server? What region? You just say North Virginia, that's all. Have you worked with other regions? No, I haven't. I haven't seen a reason to work with other regions. Inter Miami don't score. So, yeah, let's create a server then. So we're gonna go on this button right, this orange button, we're gonna click on launch. So everybody there, launch an instance. Messi's on a hat trick.
Yes.
Messi don't get hat trick only. Hey, Messi has a hat trick. So everyone is here. So you're gonna see on the right side, you have the summary right here, and it's one instance, right? One instance right here. And then here is what we're going to configure. We're going to select our options. So like I told you, Amazon sells all kinds of servers, but we're going to choose the specific server that we want. In this class, when it comes to servers, we are going to learn Amazon Linux, Ubuntu, Red Hat, and Windows. Those 4. We're going to learn operating system. We're going to learn, not in great detail because it's all the same thing. We're going to learn Amazon Linux. We're going to learn Ubuntu. Ubuntu Linux. And we're going to learn Red Hat. Enterprise Linux. This is enterprise. This is what most big companies use. It's very expensive, but I want to learn it. And then last but not least, we'll do some Windows. Windows operating. Windows Server, actually. Windows Server. Because Windows is different than the Windows laptop that you have, the Windows. It's a server version. As you can see here, Windows Server. Someone has a question in the chat. Where are you? Isabel, did you click on EC2?
I don't know where to click. All what I'm saying is console home, so I don't even know.
Console home. Are you logged in? You have to log in. Click on sign into console.
I'm logged in. I'm seeing my name, Isabel, everything.
Yes, your name is on the right, right?
Yes.
Yes. So click on, you're not clicking on EC2. You have to go to click on services and then EC2 right here.
Okay, I'm in the same place too. Let me just
click on services, then click on EC2.
I don't have EC2.
You have EC2. You do. Okay, let's finish up this. During break, I'll take a look. We're taking a break very soon. So guys, give your server a name. Give your server a name. You're gonna call this my first server. Something like that. Whatever. You give a name that you like. I don't know, Debo first server. I don't know, something like that. Debo first server. That's the name you're gonna give it. And then for the operating system, you're gonna select Linux. So you select it right there. Just make sure you click it, right? That's the first one I want to create. And then you're gonna scroll down. That's the instance type. It's T2.micro. You're creating a server that has 1 CPU and 1 gig of memory. That's what you're creating. Okay. And then to log into this server, you need something called a key pair. A key pair is what you use to log into the server. It's like a password. Because in AWS servers or any server, they don't allow username and passwords. They use key pairs. So your key pair is like a password. So you're going to click on create new key pair. If I'm too fast, let me know. I'll slow down. Create new key pair right here. And you're going to enter a name for your key pair. I'm going to enter Debo first key pair. Debo first key pair. Over 3.5 goals. And then click create key pair. Yep. Kobe, I gotta do what I gotta do, man.
RSA, which one?
RSA, always RSA, okay? Then when you create a key pair, you're gonna scroll down. Network settings. Because you want to connect to that server, The server will have an auto, it will assign the server an IP address right here. Auto assign public IP enable. For us to connect to that server over the internet, the server must have a public IP. There are two types of IP addresses: a public IP and a private IP. Please write this down. This one is important. There are two types of IP addresses: a public IP and a private IP. Every server has two types of IPs, a public IP and a private IP. A public IP changes every time you restart the server. I'll write it for you guys. It's okay. I love you guys so much. I'll just do it for you. Public IP and a private IP. Why do we have a public IP and why do we have a private IP? Anybody want to take a shot at it? I'll cash up you $5 if you get it right. The answer is actually it's in the two names. It's very easy.
Public
Private IP,
IP
the
is the
IP won't
public.
change.
Somebody just, one person at a time, please. Who wants to go first?
The private IP, the IP is not going to change. The public IP, the IP keeps changing so far the server keeps coming off and coming on again. I'm in Canada. How am I going to get my $5?
You guys don't have cash up in Canada, so forget about the $5. You can give it to somebody in class. So
Okay. I have a store credit.
You have a store credit. It's right. Public IP, that's not that, there's more, right? Public IP is public. To go on the internet, you need that's what you use the public IP. Private IP cannot connect to the internet. Private IP, let me put point number 1. Private IP cannot connect to the internet direct. Public IP can connect to the internet. This is an interview question that AWS likes to ask. I don't know why I like this question. It's easy. It's an easy question. Can connect to the internet easily. Number 2, public IP changes when the server restarts. Why does public IP change when the server restarts? Because the server can be started today in zone 1. Look at this. Where is the zones? Right here. It can be started today in a zone 1. And then when you restart, it starts in zone 2. That's why the IP address changes. Remember, right? North Virginia has how many zones? 6 zones. And those 6 zones are in different cities. Different cities have what? Different zip codes. So when a server is created in zone 1 and you terminate the server, you start a new one, it can be created in zone 6, which is Westchester, Virginia. So you will use the zip code in Westchester, Virginia to give you a brand new public IP. But once you create a server, the private IP that is assigned to that server is permanent to that server. That's why applications in the back end, everything in the back end here, in the back end, only use private IPs. Everything in the front end uses public IPs because they have to talk to users on the internet. And when the users on the internet send their requests to these servers in public, who takes their request back to the back end? A load balancer. When he takes that request, he's able to transform that request and secure the request and communicate with these servers back here privately. That's why your credit card information is always secure. Your SSN is always secure because that information is passed in public on your browser, on your laptop, but it goes to a private environment. It goes into a private environment. These servers talk to each other privately. A server talks to a server over a private IP. Let me repeat it again. Servers talk to each other using private IPs. Servers talk to each other using private IPs. They secure their communication. When you buy insurance on Geico Auto, they want to transfer your information from Auto to home insurance. Auto server will send the information encrypted through the private IP to this server. You as a human being cannot interfere between the communication between two servers because they're using a private IP address. Their communication is private. Used to communicate between servers. That's it. That's the tool I can give you for now, but you can look up more online. Private IP and public IP addresses, right? We use the public to connect to the server, while the private is between two servers. Okay? So is everyone here? Everyone is here? Network settings. So this one will be auto-assigned in public IP. If it's not enabled, we're not going to be able to connect to that server because we are trying to connect a server over the internet. So this server must have a public IP address. We have our IP address here. My IP address is right here. That's my IP address. So I'm going to go from here, connect to a server in North Virginia. So North Virginia needs to have a public IP address. This IP address is also what? What is this IP address? This one. What is this? Public or private?
It's public.
My IP is public. My IP is public, not private. That's why I'm gonna be able to take this and connect to here. Okay? I'm gonna connect to here over the internet. Using the internet. Okay? Internet. And put it twice so that it sticks. Okay? So that's that. We're going to create a security group, which is allowing everything to connect, allow SSH from traffic from anywhere. When we are connecting from anywhere, this is the IP address for anywhere. It means that anywhere in the world you can connect to this server. We're going to live anywhere. So that's that. We choose compute up here. Remember? T2 micro, 1 CPU, 1 memory. That's compute. Instance type, that's compute. Memory and CPU. Now we're going to add storage, the last thing. Storage. We're adding 8 GB of storage. And that's a server is complete. We're adding 8 GB of storage and your server is complete. Your server has compute and storage. It means your server has memory, CPU, and storage. That's it. Done. And we're going to click launch instance. So everybody here on launch instance? Launch instance. And your server is creating. Oh, hell no. Oh, hell no. And that's it. Any questions so far? Your server has been created. Want to take a little break? Do you want to take a little break?
I think you should. I think some of the people had trouble logging in, but I'm following it on pretty well.
All right, cool.
If anyone needs help, share your screen so we can help out.
Cam, let me teach my class, please. Don't teach for me.
I thought we were on break. Sorry.
So we have created our first EC2 instance. So now we're going to go to that instance and connect to it. If you want to go back to instances, all you have to do is click on instances right here. Click on instances. And you will see your running instance. So your instance should be done right now. If you see under status check, you should see 2/2 checked passed. That means it has created the instance, done all the checks and balances, and then the instance has been created, right? So with that being said, let's go ahead and connect to the instance. To connect to the instance, you're going to select this button right here. Select the instance. When you select the instance, you're going to see everything about that instance. You see everything about that instance when you select it right here. You're going to see the public IP address. So it's 35.153. That's a public IP address. You're going to see the private IP address, 172.31.36.189. You're going to see the state of the server, which is, I keep calling it server, but in the cloud is an instance. I'm calling it server just so that you know that it's a server. Our client is Firefox. We are not connected to the server yet. This is the information about the server I want to connect to. This is the public IP address of that server. So this is the public IP address. This one right here. So we're going to be connecting from this IP to this IP. So it's going from this IP to this IP. This is public IP. This is public IP. Can a private IP connect to a public IP? Can a private IP connect to a public IP?
Yes.
No.
Why yes? Who said yes? Tell me why.
I said yes because you said the private IP is for the server. So as us who is at the back end, I think we can easily connect to the public IP because it's mostly for the client.
Is that what I said? I typed it. Thank God I typed it down. What is this? Guys, please mute yourselves. Can a public IP connect to a private IP address?
No,
Why?
because privates only connect between, or they can't connect directly to the internet, and they're connecting between two servers, or the communication between two servers.
Isabel, did you get that? Public means internet. Private means internal. Public means external. Let me add it here. 1, 2, 3. External. While private means internal. We connect to the servers on the back end, not using the private IP address. I know what Isabel is onto. This is the client, this is the server. We have a public IP address, Isabel. This server has a public IP address. This same server also has a private IP. I know what Isabel is onto. Let me learn. This is the private IP of the server, right here. This server has 2 IP addresses. I said it, a server has 2 IP addresses, public and private. We are going to connect to the back end using the public IP addresses. The private is meant for this server to talk to another server privately without us, the SRE, being in their conversation. Our client only has one IP, public IP, because our client is a type of client that only connects to the internet. Do you use Firefox to type text, to type a letter? Yes or no? What is the main purpose of Firefox?
It's to browse.
To connect to the internet, right?
Yes.
What's the main purpose of Google Chrome?
To connect to the internet.
Yes. So it's for sure that Firefox will have only a public IP address. But the server is used to host applications, right? If this server is used to host an application that is in the back end, if this server that was created is in the back end, what would the server use to communicate among themselves?
Private IP.
Thank you. If the server that we just created is a server that we want to use it for the front end, what would the server use for users to connect to it?
Public IP.
But these servers back here, all servers, all of them have a public and private IP address. All of them have a public IP address and private IP address. But in the back-end servers, in the real world, on the company, we disable, you can write this down, we disable the public IP address for communication among themselves. We only allow SREs, engineers, to connect to the public IP address. That's what Isabel's point was. I see where she was coming from. And it's a good thought, Isabel. Thank you for that. That's a good thought. Only SREs are able to connect to these servers using the public IP because we're in the same network. Users from here cannot connect using the public IP. They only send their request, and the load balancer takes their request and send. These users cannot connect here. They only connect to the website. Their request is handled by the load balancer that comes down here. Okay. So now the server has two types of IP addresses, public and private. Public is on the internet. Private is internal, no internet. So how do these two servers talk to each other? There's no internet back here. How do they talk to each other? They are in the same network. When you're in the same house, do you need to call me on the phone to talk to me? When you're in the same house? Don't you just walk to the bedroom and whisper in my ears? Exactly my point. These servers are in the same network. There's something called intranet. There's something called intranet. Have you guys heard about intranet? Have you heard about intranet?
Yes.
Yes. Internet is public. Intranet is private. So Isabel, these companies use intranets among themselves to talk like this. They use the private network, while here they use the public network. Okay?
Okay.
Yes. So now that we want to connect to this server, now that we want to connect to this server, we select the server, we see everything. Public IP address, private IP address, everything here, right? If you click on status and alarms, you can see the metrics for the server. That means it's the status of the server. If it's up and running, if it's down, click on monitoring. You can see the server statistics, the monitoring of the server, how much CPU is used, network in bytes. This is what we're going to be spending most of our time in this class, looking at the metrics of the server. CPU percentage used, we have used 3.3% of CPU so far, but it's going to go back down because when the server starts, it needs to start up everything, the services, everything. So you consume some CPU to bring up services, and then you will drop back after a while. Network connections, network in, network out, right? CPU credit, packets transferred was 5.2 packets, now it's dropping down. CPU credit was high, now it's going down. CPU credit balance is flat. It's at 31.1 count CPU. So this will be monitoring. This will be your dashboard daily. You can add it to a dashboard, and that's what's on the big screen, and you're monitoring it. Imagine you have 1,000 servers to monitor. Not many companies, I think Geico has about 6,000, but they have about 200 SREs, right? You're not the only one. So, but you're going to be in a team. Let's say you're under the auto team. Auto has about 600 or 800 servers to manage. Only auto alone, right? So you'll be looking at this dashboard and, oh, CPU is dropping, going high. Let's look at what CPU is. You go in here, you run a command, run a top command. See, oh, CPU is high because of this guy. CPU is high. You see? That's what the reason why CPU is high. So when you come and see CPU is high here, you go to the server, you connect, and you check. So let's see, CPU went up here, right? Let's connect to this server and see why it went up. So we're going to go back to details, go on details, then right here, up here, you see connect. Everybody see connect up here? You can connect. Click on connect, you see these options. You have 4 options to connect. You can use instance connect, you can connect with session manager, you can connect with SSH clients, or EC2 serial console. So 4 ways to connect. You can see here, with EC2 serial console, you're not authorized to connect with this method. You haven't set it up. You have to configure the access and set it up. So it's not set up yet. Okay. Next thing, you have SSH clients. We're not going to connect using that. Session manager is not connected. You have to set it up. And the EC2 instance connect is the one that we're going to use to connect. So you see this is the public IP address connecting to. Any questions? Someone has a question? Okay, so click on instance, EC2 instance connect. You see right there, that's your public IP address. That's the username. Because we already created a key pair, we're going to use that key pair to connect. So you're going to click on connect. And then open up a browser right here. Establishing connection, and boom, you are connected to the server. That's it. You're connected to Amazon Linux. That's it. Is everybody here?
Yes, I am.
And that's it. Congratulations. You have connected to your first server. As seen in the diagram, you are in Dallas. That's your IP address, public. You're able to connect to a server in North Virginia to its public IP address. Not to the private one, public IP address. If another server, if another server independently, let's say the Zoom server, independently wants to connect to that same server, it will connect to what? Private IP. Provided it has its own private IP address. Private connects to private, public connects to private. Sorry. Private connects to private, public connects to public. If the Zoom server wants to connect to our server, the Zoom server must have what? A private IP. Is it all clicking now? You cannot connect to me if I'm a private person. You cannot come talk to me if you're a public person. That's how communication works in networking. We're able to connect to this server right here because it has a public IP address down here. But this server also has a private IP address just in case another server like himself wants to connect to him. They will connect using their private IP addresses. When they connect using the private IP addresses, they are within the intranet. They're all internal network communication. They're not in the internet. You cannot hack them. You cannot interfere with them. Hello? Any questions? All right, Chris B. And that's it. So we're connected to the server. Now let's run our first command. And the first command and the most important command. The first command and the most important command to check for performance issues is called top command. T-O-P. Top command. That's the first command you're going to learn. And that's the most important command that you're going to remember. It's the most important. There are about 10 to 20 commands that you're going to learn, but this is the most important one. This top command shows you the processes running on your server. This command shows you the processes running on your server. This command shows you questions. That's the top command. Shows you all the processes running on this computer and the ones consuming the most CPU. So this command is to check for CPU consumption. The top command is used to check for CPU and memory percentage consumption. This command is used to check for CPU and memory percentage consumption right here. CPU percent. Let me use a thing, annotator. Where is it? Draw. Right here. Where is it? Draw. CPU and memory. These two right here. That's what it's used for. Compute is used to check for compute. Top command checks for CPU and compute. What command checks for storage? Guys, when you run a top command and you see this, it's going to be changing. You will see who's consuming the most CPU. It will keep changing. So you want to capture the highest consumer and capture their process ID, 3661. We just saw EC2-user. The user that we're using to connect to this server, that's the guy consuming the most CPU. So if that's the person that's connecting, it's fine. But if you see another process that's connecting that is causing issues, you don't know you don't know the process, you can kill it. And I'll show you how to kill the process. But when you run this, if you want to cancel this, you press Ctrl-C on your laptop. Ctrl-C on your laptop. Ctrl-C. on your laptop. Control C. Control C on your laptop. Now you want to clear your screen, you type the word clear. And you hit enter and you clear your screen. Clear, enter, you clear your screen. Let me erase this.
So, if I may ask, similar, so if you want to check the storage and the CPU, just type top and you hit enter, right?
Is that what I said? I said memory and CPU.
Memory and CPU, sorry.
Yeah, you type top command. Top command shows you memory and CPU right here. CPU and memory percentage. The percentage of consumption on the server. The process, PID stands for process ID. Which process is consuming the maximum CPU and memory on this server right now? Man, showing us right here. You will see it. It keeps changing. It keeps changing. It keeps changing. So you have to capture it. You have to watch it for like 10 seconds and see. Okay, this guy's consuming 1.7 memory. Percent. You capture it. Okay? That's for CPU and memory. If you want to see storage, so you write Control C, clear your screen. You want to see storage. How much storage is available on this server? Type df-h. df space -h. You see what's available, how much space is available on this server. We created 8 GB. We have used 1.6. 6.4 is available. So we have used 20%. Right here. dev/xvda1. That's the storage mount point. 8 GB. All these other ones, we don't care about. It's dev, TM, temp, FS, we don't care about it. All we care about is the one that we created, this one. That's it. So we're going to only learn 2 commands today. The top command and df space -h. However, we have all these commands in our words. In our notes. Yeah, we do. I think we do. The notes are sent to you, right? You have these commands there. You can start practicing. Where is the notes I sent out? It's under the Gen AI folder. Gen AI, that's it. Right here, Linux commands cheat sheets, this one. There we go. Does everybody have this? Yes? Yeah, you do. Sent you the email.
No, I didn't get it.
Okay, I'll forward you the email. Roslyn, can you forward the email to Minette, please? Please.
Sure.
Yeah. So now that you're connected to a server, hello, you can start running and practicing these commands. That's how you get better with Linux. That's how you get better with Linux. Linux is the English language of IT. Control C is to kill the process terminal. Top command, all these things.
So in the real world, right? Let's say for job purposes.
This is the real world. This is the real world.
So do you use all those commands like in a job?
Not all of them. There's top 10 commands that you're going to be using, not all of them. But this is what you need to learn. If I were you, I would just spend this weekend and run all these commands on this Linux system. Try everything. You can copy it. Well, I don't advise you to copy. I want you to type it. The only way to learn this thing is to type it and type it in. You can copy like this, but I would like you to type it. You can copy and come on here and you paste it, you run it. You see the information. Union-A tells you the information about the server and shows you the private IP address of that server. If you want to find a private IP address server, this is what you type. That's a private IP address server, 172.3.1.6.3.9, right? But the top 10 commands that I'm going to teach, I already showed you 2. Top is what the most important command, because it shows you how much percentage memory and CPU is consumed here. Control C to cancel. Type clear your screen. The next one is df-h. Why am I showing all these 2 commands? Because CPU, memory, and storage are the most important things. CPU, memory, and storage are the most important things that we care about as SRE engineers. If your storage is low, you will see here under availability, under available, you will see low. We have used 20%. Whenever you see 80%, 90% here, oh, the problem. You need to add more space. As SREs, our job is to add more space. If a server has no space, guess what? Users cannot buy flights online. Users cannot place order on Amazon.com. Because when users buy flights online, their information needs to be written to the server. So if there's no space on the server, where would the information be written? The server will hang and the application will freeze because it cannot write. And the users online cannot connect, cannot buy flights. They're clicking submit, and it's not going because there's no space on the server. So you, the SRE, will come and connect from the back end. And you come and log in and you run df-h. And you say, oh, it's at 95%. Let me go and add space. You go back to AWS. You go to the server. You go to storage. You look at it. Oh, it's full. Look at it. It's full. There's so much read on the server. Too much write on here. You go now. You go to volumes. You go to volumes. And you create a new volume. And you add it to that server. That's your job. You laugh. If you see they pay you 20,000, never nothing. You are not creating anything from brand new. You're maintaining. Do mechanics do oil change? Hello? Do mechanics do oil change? Yes or no?
Yes.
So would you do an oil change on your server? Yes, you have to.
I have a question, please.
Yes.
Okay, as you have to, when you increase the volume, the space of your server,
I will show up here. It will show
you
you add
you
here.
have to make a request first to the company because
Yes, because it's costly, because it's expensive.
yeah.
Somebody has to approve it. Thank you, Isabel. Now you're getting it. I just say you have to create it because I assume that you have gone through that process. But yes, there's a process called ServiceNow. ServiceNow is a tool that we use on the job. ServiceNow is a company, right? ServiceNow, you're gonna create a ticket. You're gonna create a ticket, right? Saying that, oh, I'll request to create more volume to add to this instance. Sometimes you may not have be the one to do it. The cloud engineer will do it, right? But you're the one who will notice it. You discover, oh, there's no space here. Then you can go create a ticket. Hey, we need to add more space to instance ID. You give the instance ID. You put the instance ID in a ticket. Copy this ID. You go to your ticket, create a ticket. Hello, team. Need to add more space. Instance ID this. Instance ID is add. You copy this information right here. You put it in your ticket. So they can see that the instance ID only is at 95%. They don't have to go and log in and check. You have already given them the output of df-h. You copy that, you put in your ticket, you put a request in your ticket, you submit a ticket. Maybe there's another team called the cloud team that will create a volume. And then they add it. Or if your cloud team is merged with your SRE team, If it's not a very big company, there's one team. You go, you create a ticket. When your manager approves the ticket, you go and create it, and then you close the ticket. How do they measure your performance? How many tickets you resolve in a month. If you work in support, they measure your performance by how many tickets you resolve in a month. If tickets are created by somebody else, you don't create tickets. You go pick up that ticket. The ticket say, oh, can you check for space on instance ID number? You go and open it. You check for the space. You copy the output, put in the ticket, submit it, close the ticket. That's one ticket resolved. The minimum tickets you need to resolve in a month is 35 tickets in any company. Amazon is about 50 tickets a month. But the minimum companies is 35 tickets. Some companies are lower than that. I don't know. But the lower the ticket, the lower they pay. The higher the ticket resolution, the higher they pay. But yes, you're going to work with tickets. Thank you, Isabel, for bringing that up. You don't just create things. You have to request. You have to put a ticket in. And someone else approve it. Because when you create a volume, it's money. Everything you create in AWS is money. Money, money, money. Okay, I know we're above time. So now we're going to go and terminate that instance. Everyone go back to the instance. Go back to your instance dashboard right here. And to delete your instance, it's not the word delete, right? It's running right now. To delete it, you go to instance state, and you click on terminate, which is delete. Terminate instance. You terminate it, the connection would disconnect. You come here, you see the system will now power off. It's gone. So the connection between the client and server has been broken because we have sent a request to turn it off. And so this connection is broken. It's gone. And that's it. We are not connected anymore. If you can refresh it, you will say fail to connect because the server has been terminated. In IT, we call it, when you see someone say, hey, blow it away. Blow it away means like, delete the server. That's what blow it away means. Blow it away. Any questions? All right. All right, guys. So if you want to practice, you can go ahead and create EC2 instances, play with the Linux commands, terminate them. For this weekend, your homework is to create an EC2 instance and practice the Linux commands. That's the homework. I'm going to send you an official email with steps on how to connect on EC2 instance. And your homework is just to connect to the EC2 instance and practice these commands. All of the commands. That's your homework. I'm not going to ask you to submit anything. I'm going to just trust that you're an individual that wants to learn. So you're going to do it on your own. I'm not going to ask you to submit anything. So you have these commands, create an EC2 instance, connect to the instance, and practice those commands. We need to know how to connect to a server and run those commands on the server. That's our job as SREs, because that will be the work that we're going to be troubleshooting going forward. When we get to the end of the class, we're going to learn some ServiceNow. I have a ServiceNow environment. I'll show you how to create tickets, how to submit tickets, how to open up tickets, how to resolve tickets, and so on. That. We're also going to learn Jira tickets as well, and some Agile. And we have a Scrum Master in class, so we're lucky. We're going to learn some Scrum. I want to have some stand-ups. All right. Any questions for me? That's it for today.
Minette, please, can you shoot me your email, please? Okay.